So we're going to look at the distributive properties for a second. So if I had something like A times, and I'll just put B plus C plus D, then I could distribute the A. I could multiply it in. And so it would be AB, A times B, plus A times C, plus A times D. That's an example of the distributive property. Now what we're going to do when we're factoring one of the things we want to be able to do is to go the other way. So we look for a greatest common factor, something that they all can be divided by, and we take that out, and then we divide each term by what that greatest common factor was. So you get back to the original. So it's kind of like we're factoring, we're turning something into multiplication, A times this parenthesis. That's what factoring means, make it multiplication. And we're doing that by a method of greatest common factor, okay? All right, so I've got a few examples here. This first one says factor. Factor means we want multiplication. Right now we have overall addition. We have stuff plus stuff plus stuff. That's addition. And we want stuff times stuff, which I know that's not real technical, but that's what we're trying to do when it says to factor. Okay, so I look at the 9, the 6, and the 21, and I say, well, what number could go into all three of those? And the answer is 3. So I'm looking for the greatest common factor. We did that in the previous video. But 3, and you could break it down into like that little chart I had. So 3 is something that will go into all of them. Now, let's look at the variables. X squared. Oh, I don't have an x. So they don't all have an x. That won't be part of our greatest common factor. Now let's look at the other variable, the y. We got a y squared, and a y cubed. So all of them have at least a y squared. They all have at least y, okay? So that's what we're doing. That's the greatest common factor. Now, write the greatest common factor first, 3y squared. And now what you're going to do is you're going to take each one of those terms. So 9xy squared. And some students like to do it this way. But what you're doing is you're taking each one of those and you're dividing it by the 3y squared. Now, I don't usually write this out, but I'll tell you how I think about it in just a second. But that's what we're doing. So you look at the first term, and how does that work? Well, 3 goes into 9 3 times, and then you have an x, but the y squareds cancel out. So you could get like a canceling pen here. 3, and then the x is going to stay, and the y squareds are out. So you have 3x. And the next one, 3 goes into 6 2, and then the y squareds are out, so you have 2x squared. And then the last one, 3 goes into 21 7. And then y squared goes into y cubed, but you have a y left over, so 7y. So I've kind of got a different color going here, but anyway, that's what the 3 terms are going to be right here. That's what's going to go inside the parentheses. Now, I can write that 3x plus 2x squared plus 7y. Now, a good idea is to check this by distributing. So we think this is our answer. I'm pretty confident, but you can check it then by distributing. So if I multiply here, do I get 3 times 3 is 9x y squared. Then when I multiply here, 3 times 2 is 6. I have the x squared and I have the y squared. And then when I do the last one, 3 times 7 is 21, and I have a y squared and a y, so that's going to make y cubed. Now that has to be what the original was. So you can always check your factoring by multiplying it out. That's one of the great things. And we did it right, yay, so check. Okay, all right. So that's one way you could do the problem, but that's what we're doing. That's what we're thinking about, and that's what we're trying to do. All right, let's look at this next problem. So I only have 2 terms this time. I have a 2x cubed and a 12x squared. So I think about 2 and 12. I'm going to say my GCF is, and I don't even always write this out to the side, but we're just kind of getting started here. 2, because 2 will go into both of those. And then I'm going to need an x squared because they both have at least x squared. So that's the GCF, 2x squared. And then this is how I usually do it. I think about, well, look at the first term. If I took out a 2 and an x squared, what do I have left? Just an x, right? And then I kind of mentally think about, okay, do those two multiply to be that first term? Because that's what I've got to have. And they do. So plus, now I think about the 12. Well, if I took a 2 out, I'd have a 6. And if I took out the x squared, then I don't have any x's. So yeah, that looks good. And then I mentally think, okay, 2x squared times 6 is that 12x squared? Yes, so this is the answer. You can write out a formal check if you want to. Why is it factored? Because you have 2x squared times x plus 6. Now it's multiplication here. Instead of stuff plus stuff, I have stuff times stuff. Okay. Hopefully you'll get the hang of it. We do a lot of these. I hope it's making sense. Okay. So our last one, it says factor. So I look at all three terms. I look at the 15, the -3, the 6. What can come out of all those? 3. So I didn't write GCF. I've been doing that. GCF. So I'm going to have a 3. And then don't worry about the negative sign. That's going to come up when we write the terms. Okay. So then look at the x's. I've got, let's see, x cubed, an x squared, and an x. So they all have an x, but they don't have more than that. And then I have a y squared, and a y cubed. So they all have a y. All right, that's the GCF then. I write 3xy, and then parenthesis, that indicates the multiplication. And then I think about, well, if I took a 3xy out of each term, what do I have left? Well, 3 times 5 would be the 15. I've got an x. I need x squared here. I've got a y, so I don't need any more y's. Minus, okay, it's going to still be a minus sign there, so don't worry about that. The 3 came out, an x came out, so I have an x left over. A y came out, I have a y left over. Okay? Plus, now 3 goes into 6 2 times. The x came out, a y came, so how many x's left? A y came out, so I have y squared. Okay, I believe this is the answer. But I can always check these. I always think students should get 100% on the factoring test because you can always check them. It doesn't usually work that way. Okay, so when I multiply, 3 times 5 is 15, x cubed, y. Yeah, that, okay. Then these two, minus 3x squared, y squared. And then I multiply these two, 6 plus 6, x, y cubed. Now, if that's what I started with, then we're good. We did it right. And it looks good. Okay, so this is just the check. But it's a good idea to check these.